In this problem, we continue our investigation of the open top box problem in Module 3, Investigation 1. We have already defined a function that accepts the side length of the square cutout measured in inches as the input quantity, represented by x, and produces the volume of the box that results as the output quantity, represented by f of x. The rule for the function we need is x times 11 minus 2x times 8.5 minus 2x. We have also determined the acceptable input values that will produce an output value that makes sense in the context of this problem. Negative lengths for the side length of the square don't make sense. They are impossible for us to cut out. Also, side lengths that are larger than half of 8.5 make it impossible for us to physically cut the original piece of paper in a way that produces a box. So, the possible values that make sense practically as input values, some call this the practical domain, are the values between 0 and 4.25, or half of 8.5. Also, we have determined that the output values we get when we input the values in the practical domain will be between 0 and a value a little over 66. We can call these possible output values the range for this practical domain. Question 5 in Module 3, Investigation 1 asks you to use a calculator to determine a few specific output and input values in this situation. It asks you to use a calculator to find the value of the maximum volume of the box, the side length of the square cutout that produces the maximum volume, and the side length of the square cutout that produces a volume of 25 cubic inches. Now we will show you how to use a calculator to answer question 5. We first need to enter the rule for our function using the y equals key. When you are entering the rule, be sure to use the x variable key on your calculator When we hit the graph key, we see a graphical representation of all of the input and output values defined by this rule, or this is what we usually call the graph of the function. The default window in this calculator does not work well for us to see the graph, so we must change the window according to the practical domain and range that we are interested in. Under Window, we change the xmin and xmax values to numbers that will include our practical domain. We must also change the ymin and ymax values to numbers that will include our range. Now we can see the graph of our function more appropriately. We can approximate the maximum value using the second calc key and choosing maximum. We then must use arrow keys to set a left and a right bound around our maximum value of interest, and then it asks us to enter some guess. We set these bounds and enter our guesses by hitting the enter key. Now the calculator produces the maximum value and the input that gives us the maximum output value. You will need to do this on your own calculator to find these values. Next, the problem asks for the input value that produces 25 as an output. Well, we can define a function whose output is always 25 by entering y equals 25. Then we can determine the input values of our function that produce 25 as an output by finding the intersection point of this horizontal line with the function that produces the box volumes. We use the second calc key and choose intersect to determine these points of intersection. We must place our cursor close to the intersection point when we choose the first and second curve and enter a guess in order for the calculator to produce an intersection point that we are interested in. Notice there are two such input values in this problem that will produce a box with 25 cubic inches. Here we are placing our cursor close to the intersection point for the calculator to provide the second. You will need to do this on your own calculator to find these values. For question 6, the problem asks us to consider that x represents the side length in inches of a square and a represents the area of the square in square inches, so that a equals x squared. In this context, the problem asks us to write in words what various algebraic expressions would represent. Let's consider the expression x plus 3. This expression represents a length. It is the length that is 3 times longer than the side length of the square. With this in mind, part C gives us the expression x plus 3 the quantity squared. That expression represents the area of a square whose side length is 3 inches longer than x. Notice that this algebraic expression can be expanded to x squared plus 6x plus 9. This new form of the same expression will still produce the values for the area of a square whose side length is 3 inches longer than x. Submit your answers to all parts of questions 5 and 6 in Module 3 Investigation 1 using your instructor's preferred method by the time and date that your instructor has identified.